Hi, and welcome back to Tim Time Projects. I was at a ham fest a couple weeks or a week or so ago at down in Butler, Pennsylvania. It's the Breeze Shooters. It's actually a pretty big ham fest for the area. And no, I didn't buy this, but a friend of mine bought a Simpson, really nice shape. So it made me think, now I got to go home and tear mine out. So I did buy this a while ago, and I think I might have even highlighted it in the video, but never really used it. This is basically what I learned on back when I was in high school and took electronics, and that was back in the 80s. So, well, actually in the late 70s. So these have been around for quite a while. And when I got this came in this case and everything. And pull this out. When I got it, this battery door was missing, and I was able to get one. I can't remember if I actually went to a Simpson website, but the battery door was still being made, so I was able to get a replacement. I don't keep batteries in it generally. All the batteries are for the resistors, or for testing resistors, and for as often as I would use this for doing that, the batteries would probably go dead and ruin the inside. So just open that up real quick and give you a look. Now there's different generations of the series of the 260. This one claims it's a Series 7. At least the book says Series. It's probably cracked now. No, the book says Series 7 or 7M, and I believe the M's the one with the mirrored background, so that you can see the reflection of the meter to make sure that you're staring at it straight on from any angle. This does not have the M, so it's just the 7. But here's where the batteries would go, and throw a battery in and we'll give it a test, and we'll just run through some quick tests and even compare it to the Fluke. So let me get that ready. Alright, and here's the batteries. Odd trying to find a D battery. So many things do not take them anymore that they're hard to find. And the 9-volt has a little compartment it literally slides into. And this would be the fuses for the current. So I'm not going to leave the batteries in, so I'll just leave the cover on, because it's not going to hurt to put the cover back on. What the heck? There you go. Okay, cover's on. All right, let me get this set up and we'll run a few tests and go through everything. I'll be back. All right, I had to do everything I could to get things to show up, because the glare from this is incredible. Anyhow, so you'll notice it has the switch itself has different settings, and I'll point down to that in a second. But I'll show you what we're looking at. The Fluke says about 0.64 volts coming from the DC power supply, and if you look at this, that's exactly 6, and each one of those hashes is 2/10. So 2, 4, so that's exactly 6/4 on the 0.1 scale. So, or I'm sorry, on the 1 scale. So that would be 0.64. So that's pretty darn accurate. But I'll show you what I mean about the face of the meter, not the face, but the front plate of the meter. So if you look here, you'll see that there's all kind of places to put your leads. Here, 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 here. So down here would be the regular plus and minus for your regular readings. But if you wanted a very intricate reading, say around 1 volt or less, you could plug into that, and then you read it. The scale's either for the 2.5 or the 1 volt. So if I put it down here, remember we were just on the other scale, and we were showing, we'll zoom out a little bit so you can see what happens. It's just to make it more intricate of a reading. So here, if we go up in here, we're on the 0.1 scale, so that'll be like the 10 scale, move the decimal over twice. But if I go down to here, then we're on the 2.5 volt scale, so we go to the, here's the 2.5 here. That's for AC. Here's 250. We would move the decimal over twice. So over here we're at 50, and each one of those hashes is about 2, so I'm trying to read that. Okay, the noise is gone. So each one of those hashes is 5. So 50, and then the first hash would be, I don't know if you can see, I'm going to try and zoom in and see if you can see that. Hopefully it'll focus. Here comes the noise again. So it's at 50, first hash would be 55, 60, and the second hash is 65, so it's actually just before that. So that's again about 0.64. Pretty interesting, or pretty good, huh, for an old analog meter. Alright, so let's go up and let's just turn it to, we'll just say, now let's read it, we're going to put it on the 10 volt scale. So we'll just shoot it up around 10 volts. So I got to go back here and set this. No, we don't want 10 volts. If we're on the scale, we'll go to 8 volts. So we don't want to peg it. How about 8.5? 8.48. That should be about 8.5. So I kicked the meter here. Oops. Wrong meter. So let's see. There's 8, there's 9, you're about exactly in the middle, so that's 8.5. And that's on that meter, and we can look over at the fluke, right beside it, and 8.48. Pretty good, huh? So let's just try, here's amps and microamps you can do. They have, if you're going to do something big, up to 10 amps, right here you use the plus and minus right through there. They have down below, let me see, let me get back onto that meter. Alright, so if you're going to test something 10 amps, you'd go right into these two. They have the 50 microamps and also 250 millivolts. So that's the lead you'd use for here, and then you'll see that that's split. Where is it? 50 volts is also the microamps, but you would use this lead instead of this lead for your positive. Just the way they, you know, instead of having a switch with like 1,000 different positions, it just chooses different leads. Here, this one's kind of interesting here. Output. No, it doesn't put anything out. What that does is you can check for ripple, like on a power supply, or any AC output that's on DC. Alright, I have that signal generator set up like it's a really, really bad power supply. So I have it set up at 6 volts DC output. And then if you look up top, there's a going to be an AC wave on that. It's 500, so half a volt at 60 cycles per second, 60 hertz. So we'll take a look at that. We'll take a look at it on the Simpson meter here. All right, so let's get this. So the first thing we're going to look at is just the DC component to see, do we have 6 volts? So let's put our negative on here. This is where the power supply was connected before. Alright, everything, let me turn the power up. Yeah, generator's now on. Okay, so the fluke here is saying 6 volts exactly, and this is saying almost exactly 6 volts. It's just a slight hair over it. Alright. So, let's just say like we have a hum. We're like, well, where's that hum coming from? So we could either look at the AC component like this, we'll just turn it on. I'm going to pull this side. We'll turn it on to AC. And we're looking at we're getting the AC component with the DC, so it's actually looking at both of them. Let's see, this guy here, this guy will just give us the half a volt. But with this, if we wanted to see just the AC component only, we plug it into here, and then we'd adjust this scale. Now the thing that I learned here is you look at it, we're looking at 2.5 volts. So that's going to be on the AC scale, so that would be the 25. We'll just move the decimal point over. We're saying basically a quarter, not a half, that's a quarter of a, yeah, I'm sorry, that is 2.5. It's a quarter of a volt, not a half a volt. Now in the manual it tells you that if you're not basically in the audio frequency range, you can expect inaccurate readings. So if I move this up, we'll just say to 1000 hertz. See what happens. So let me set the frequency to 1, we'll go kilohertz. 1 kilohertz. 1 kilohertz, we go half a volt. And the fluke's shown us half. So it has to be in that range. And I know that I've looked at readings with this. Let's just take a look at, say, 10 kilohertz and see, when does this start to lose it? Okay, there's 10 kilohertz. Still pretty accurate at 10. Still pretty accurate at 50. Or are we now at 100? 100 kilohertz, it's still right about there. 200, it's coming down ever so slightly. 3, 4, we'll say 500 kilohertz. I can see now it's dropped below the 0.5. So I know when you get up to a megahertz, it's dropped, not substantially, but it's dropped some. Now the fluke isn't reading anything, oddly enough. See that over there? I didn't even pay attention when that lost it. Alright, so this is starting to lose it a lot earlier. At 100 kilohertz, it's only shown 0.43. So anyhow, that's kind of the difference. This one, just leave it on the volt scale and it'll take just the AC component, whereas this one, you actually go to the output and it'll eliminate and take only the AC component. Whereas when I had it on the AC scale, it took both the AC and DC and gave me that 6 volts with the half a volt on top of it. All right. So let's do an ohm test with it. Let me turn all these voltages off. Let's get a, oh, I think I have a resistor laying around. Here we go. Let's just throw a resistor in here. Voltage is off. We're going to put this one on ohms, and we're going to put this one on. What do I have? We're going to do R times 100, jumper the leads together, zero this. Alright, there's zero. Let's get this in here. This is a resistor I picked. It's the same one I was looking at. I think it was 33 or 330 ohms. So if we're using the R times 100, it should be about 33. So that's 2, 3, just over 3. So that's correct. Let's look at it on the Fluke, which is a digital one. Let me get the Fluke leads. In here, this is saying rate 296. So rate, this is showing just a little bit under 300. All right. So let's go back. Oop, we're just right over there. Back, we're showing right about 3, I believe, with this one. Can't get to grab these alligator clips real good on that one. There's this one, and here's this one. Actually, it is just before the 3. I was counting backwards, just before the 3, so that's pretty darn accurate. So let's see, let's look. We have another one, which is I think up in the K ohm somewhere. This is an old resistor from the Philco, I believe. Where's my other lead? There it is. Alright, this one's 130, according to the Fluke, it's 136, 135.9, 136 K ohm. So we'll put this at R times 10. So what would that be? That should come out to 13.6 times 10,000. That's 10,000, not 10. So let's zero our leads. That's pretty close. There we go. And what are we saying? 136K. So what I say, it'd be about 13.6. So that is almost at 14. So 10, 11, 12, 13, about 13.5. So again, pretty accurate. So there it is. I think a lot of times I just want the instant gratification of throwing the digital meter on it that does everything in the world, and ranges itself and everything, and there's a bunch of different leads down here to think about. But this is definitely an old school way of doing things, and it's still completely accurate, and it's a very high impedance. I forget what it is. But I don't know, it's what I learned on, probably what a lot of people learned on. There's probably tons of these out there in the schools. But still a very accurate meeting, and definitely a piece of history. So thanks for watching. I hope you'll maybe dust off your Simpson meter and use it.